Alright, in this video we're going to look at the basic definitions of the 6 trig functions. So problem number 2, given a right triangle ABC with a right angle at C and da-da-da-da-da, so I guess we should draw it. So here's my right triangle right here. Okay. Alright, let me zoom in a little. Shapow. So it says ABC with a right angle at C. So let's call this A, and this will be my B, and this will be my C, ABC. Okay. A is equal to 3. Okay. So when they make a lowercase a, you're supposed to put it across from angle A. And they said that B is equal to 6. So when they say side B is 6, you're supposed to put it across from angle B. Alright, now find the 6 trig ratios. Well, to do that, we need to find the hypotenuse. So what do you think I'm going to do? Pythagorean theorem, man.
Are you do like the last one?
Yeah, just like the last ones we did. So, scribble, scribble. Right, now I'm going to do it for 6 squared plus 3 squared is equal to the hypotenuse squared. So that's 36 plus 9. What's that? So 45 is equal to the hypotenuse squared. So the hypotenuse is equal to the square root of 45. Okay? Now that's 9 times 5, so that's going to simplify down to 3 radical 5. But I'm going to leave it like this for now and see if I need to simplify it later. So the hypotenuse is radical 45. Okay, what of it? So the 6 trig ratios. For angle A, okay, so focus on angle A right here. So the trig ratios are, so I'm going to do sine of angle A, so that's opposite over hypotenuse, so that's 3 over radical 45. Cosine of A is adjacent over hypotenuse, so that's 6 over radical 45. And tangent of A is opposite over adjacent. So that's 3 over 6, that's 1/2. Okay? Now, I feel like I should reduce these because I see the 3 up there. Look, let's go to the black screen for a second. If you've got radical 45, there's a perfect square hiding in there, isn't there? Right? Isn't radical 45 9 times 5? Okay, 9 times 5. So what's the square root of 9? 3. That's why this is going to become 3 and then radical 5. So even without a TI-30XS multiview, you should be able to reduce a basic radical. So 3 radical 5. Okay? So that's going to make all these become, alright, I'm just going to replace these. So this is 3 radical 5. 3 radical 5. Okay? So you see how these 3's are going to cancel each other out and make 1 over radical 5. This 3 is going to go into this 6 and make 2. So 2 over radical 5. Alright, so these are the first 3 trig functions. Now for the other 3, will be reciprocal. What's the reciprocal of the sine function? Secant. I want to know the name of it. Alright? And that's why I looked at you to indicate that I heard you say it, sweetheart. Yay! So, the reciprocal of sine is cosecant. Not secant. So, cosecant is the reciprocal of sine. So that's going to be radical 5. Okay, the reciprocal of cosine is secant. So that's going to be radical 5 over 2. And of course, cotangent is the reciprocal of tangent. So that's going to be 2. Okay, so those are the 6 trig functions. All right, so that was problem number 2. Problem number 3 is just the definition of these things. Okay, so cosecant theta is the reciprocal of sine. So that means it's 1 over sine theta. Secant theta, well, that's the reciprocal of cosine. So that'll be 1 over cosine theta. And cotangent is the reciprocal of tangent. So 1 over tangent theta. Okay, that's all that is. So those are your basic trig functions. All right, for number 4, we are evaluating these trig functions at some special angles. All right, the special angles are like pi over 6, pi over 3, pi over 4, or pi over 2. And all of these, 6, 4, 3, 3, all right, this one's like a whole number. These are all special angles. So hopefully you did what you're always supposed to do and immediately write down your 6 values. All right, somewhere on scratch paper, somewhere on scratch paper you should have your 6 values written down. So at the beginning of any trig assignment, you should write down the 3 yellow values and then fill in the 3 white values. These 6 values should be staring you in the face. Okay, what of it? So, tangent of 5 pi over 6. Now, as soon as I see the 6 down here, in the back of my mind, I'm thinking, okay, the reference angle is pi over 6. So, it will help me to understand that this is going to be the same thing as the tangent of pi over 6, except for maybe it's going to need a negative sign on there. All right, so just stay tuned for that. Tangent is sine over cosine, though. So this is going to be the same thing as, so tangent is sine over cosine. So this is going to equal sine of pi over 6 over cosine of pi over 6. We have memorized these two things, I hope. I really, really hope. What's the sine of pi over 6? Right from the cranium. That's 1/2. Okay? What's cosine of pi over 6? That's radical 3 over 2. Okay? Now let's talk about whether or not these are negative or positive, though, before we go any further. The actual angle is 5 pi over 6. So look at a little unit circle over here. Okay? I'm just drawing this to know what quadrant we're going to be in. So I'm doing my little pi over 6s like I do. Alright, pi over 6s are the hardest ones to draw because they're small. Cover up that mess I just made. Alright, so I got all these pi over 6s. So look where 5 pi over 6 lands. Alright, because there's 1, 2, 3, 4, 5 pi over 6 is right here in the second quadrant. So remember, sine is the y value. So that's going to be positive in this quadrant. Cosine is x value. So that's going to be negative in this quadrant. So I have a positive divided by negative. So my overall answer is going to have to be negative. So I'm going to go back and put a negative back there. Anyway, what is 1/2 divided by radical 3 over 2?
1 over radical 3.
It's 1 over radical 3. Okay, so my final answer, I'm going to have negative 1 over radical 3. Okay, remember the denominators cancel out, so that's why I'm just doing 1 over negative radical 3. So that's the answer for part A. Okay, look at part B, sine of negative pi over 4. Obviously, the reference angle is pi over 4. You're staring right at it. So this is going to be the same thing as the sine of pi over 4, except for maybe I should put a negative in front of it. I don't know yet. But what's the sine of pi over 4? Is this one that we memorized? Yeah, it's 1 over radical 2. Okay, 1 over radical 2. So that's the answer, except for we need to check and see whether or not we need to put a negative sign on it. To check that, we draw a picture of it. So here's my unit circle again. All right, I'm drawing a picture of negative pi over 4 right now. Okay, so here we are, and here's pi over 4 happening. These are pi over 4s. So I'm supposed to go negative pi over 4. So negative pi over 4 is clockwise. So negative pi over 4 is going to be right here. Sine is y value. So in this quadrant, it's going to be negative because it's low. So I will need a negative on this. Okay? So that's why my final answer is negative 1 over radical 2. All right? Any questions on that one? All right, look at C. Negative 2 pi over 3. Again, start with the reference angle. What's my reference angle going to be? Right. See the pi over 3? There's my reference angle right there. So this is going to equal the same thing as tangent of pi over 3. Except maybe it needs to be negative. That's the only thing that could be wrong about it. Okay? I know that tangent is sine over cosine. So I'm thinking sine pi over 3 over cosine pi over 3. All right? These are right on my little chart. Sine pi over 3 is radical 3 over 2. Cosine is 1/2. So that means I've got radical 3 over 2 over 1/2. I need to think about whether or not it's going to be positive or negative, though. So look at my unit circle real quick. Okay. Negative 2 pi over 3. That's what I'm drawing a picture of right now. All right, the original angle, negative 2 pi over 3. So pi over 3, so I'm cutting it into 3 pieces. Okay, so these are pi over 3s. If I go negative 2 pi over 3, I'm moving in this direction. Did it say negative 2 pi over 3? Yeah. All right, so that's going to land me right there. Okay, in this quadrant, which would be the third quadrant, sine, which is the y value, will be negative. So I'm going to need a negative on that one. Cosine is also negative because it's to the left, and that's x value. But a negative divided by a negative is a positive. So my final answer is actually going to be positive. Okay, so the denominators cancel out, so it's really just radical 3 over 1, which is just radical 3. So that's my final answer for C. Okay? Any questions on that one? All right. For D, cosecant. What do you know about cosecant?
It's the opposite of sine.
It's the reciprocal of the sine function. So I'm just going to start off by asking myself about the sine function. And then whatever I get in the end, I'll just do the reciprocal of that. So, so let's see. So I'm asking myself, what's the sine of 4 pi over 3? Okay, so in my mind I'm going to go, all right, that's going to be the same thing as the sine of the reference angle pi over 3, except for maybe it needs a negative in front. So I'll worry about that later. Sine of pi over 3. That's right on the list, yeah?
Yeah.
Sine of pi over 3, that's radical 3 over 2. It's one of the 6 that we have immediately. So radical 3 over 2. Okay, but maybe it needs a negative sign on it, so I'm going to worry about that real quick. So I do that by drawing a picture. So here's my unit circle. There, I'm doing 4 pi over 3. Here's some pi over 3s happening. All right, those are pi over 3s. I'm doing 4 pi over 3. So that's 1, 2, 3. 4 pi over 3 will be right here. Sine is a y value, so that'll be negative down there because it's low. So I will have to put a negative on this. Okay, so that's the answer for sine. But what I really wanted was cosecant. So what do I have to do to this? Yeah, I got to do that reciprocal. So the true answer is going to be negative 2 over radical 3. Okay, I had to do the reciprocal at the end. So that's the answer for D. Any questions right there? Okay. Look at E. First of all, secant. What do I know about secant? That's a reciprocal of cosine. So I'm thinking to myself, okay, what's the cosine of 7 pi? Whatever the answer is, I'll do the reciprocal of that. And that'll be my answer. Okay, these ones that are nice whole numbers like this, these are the easiest of all. Sometimes they're so easy they confuse you guys though. So watch really carefully. It's all about just drawing the picture. Okay? So here's my unit circle. Right? So there's pi right there. So look at this. If I wanted to go 7 pi, here's what that would look like. All right, starting from positive x-axis like you do, here's what 7 pi would look like. So do you get that if I go halfway, that's pi. So that's 1, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. All right, so the key is if you count all the way around, do you see that 7 pi will land you right here? Okay? And so focus your eyes on this spot where we're landing. Now the coordinates, when you're right on the axis like this, it's not really about the chart anymore, all right, because we don't have a reference angle. Instead, we just straight use the coordinates. Here's what I mean. Like all the way around the circle. What are the coordinates of these points? Over here on the right, what are the coordinates?
0, 1.
Backwards.
1,
This is 1, comma 0, right? Over 1, up nothing. What is it up here at the top? 0, 1 on the left? Negative 1, 0, and on the bottom? 0, negative 1. All right? These are what you use when you're on the x or y axis. You use the coordinates themselves. Remember, every point is a cosine, comma sine. Now, at this moment, I want the cosine. So I should be looking at all the x values, right? Cosine, 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 cosine. But it's all about the one that we are actually looking at, though. It's all about this one. All right? So the bottom line is the cosine of 7 pi is what? It's negative 1. Okay? Because 7 pi is this spot right here, and the cosine is the x value. So the cosine is negative 1. But we want the secant. So what do I need to do to this? Yeah, I need to do the reciprocal of this thing, right? So the reciprocal is going to be 1 over negative 1. But what's that? It's still negative 1. So the final answer is going to be negative 1 either way. Okay? So it was really simple, but yet This is one of the most commonly missed problems that kids have. All right, one more. This will be the last one on this video. Cotangent. What am I thinking in my head right now?
Thinking about the reciprocal of sine.
It's reciprocal of tangent. So I'm going to ask myself, what's the tangent of negative 3 pi over 4? Okay, that's what I'm going to deal with. And then I'm going to think to myself, okay. This should be the same thing as the tangent of pi over 4, except maybe it needs a negative on it. That's the only difference. Tangent of pi over 4. Well, now I'm thinking tangent is sine over cosine. So I'm thinking, what's sine of pi over 4 over cosine of pi over 4? Well, I look at my handy-dandy chart. I've got my sine and cosine of pi over 4 right here, one on top of another, ready to go. What's the tangent in that case? It's going to be 1, because the top one divided by the bottom one, they're the same thing. This divided by that is 1. Okay? So I had radical, 1 over radical 2 is the same thing as radical 2 over 2, by the way. So that's going to be 1. But I need to worry about the positives and negatives of this situation, though. So before I, get too carried away, let me look at my unit circle one more time. Okay? I'm dealing in pi over 4, so I'm going to draw pi over 4. So this is what pi over 4 looks like. Now, looking back at the original angle, it's negative 3 pi over 4. So I'm going to go negative direction, 1, 2, 3. So that's going to put me right here. So here's where I land, where I just put that dot. So in this quadrant, the third quadrant, sine and cosine are both negative. So this would have been negative, and this would have been negative. But a negative divided by a negative is a positive. So I'm going to get positive 1. But that was the tangent. What about the cotangent?
Still 1.
Yeah, so the cotangent is still going to be 1. Because the reciprocal is still going to be 1. All right. That's going to do it for this video. I hope it was helpful. I'll see you on the next video.